Hello friends, this video sets part 1 is brought to you by examfear.com. No more fear from exam. In this video we will learn sets. In sets we will learn definition of sets, roster form and set builder form, empty or void sets, finite set and infinite set, equal set, subset, proper set and supersets, singleton set, power set and universal set, open and closed interval, Venn diagrams. Operations on sets such as union, intersection and difference, and complement of set. Let's start. What is set? Set is a well-defined collection of objects. Please note, it is nothing but collection of objects that is well defined. For example, when I say players of Indian cricket team, this is one set. When I say, let's suppose I'll say players of Indian cricket team. So this is one set, and this can include members such as Sachin, Ganguly, Dhoni, Sehwag, etc. So this is one set. Plus you can have more people, but this is one set of objects. This is players of Indian cricket team. Similarly, when I say rivers of India, I can say this will include rivers like Ganga, Kaveri, Yamuna, etc. So these are all set of rivers of India. Similarly, when I say students of school ABC, let's suppose I say student of DPS school. So these are the students of DPS school. Students of DPS school. So this can have students like Chintu, Anand, etc. When I say set of members of family, so this will include your dad, your mom, you, your sister, your brother, uncle, auntie, etc. So when you see this, these are all sets of various examples of sets. For example, now let me see the cricket team set. I have members like Sachin, Ganguly, Dhoni. So let's suppose this is a set of Indian cricket team. So Ricky Ponting, if you say, this guy will not belong to this set because Ricky Ponting is not part of Indian cricket team. But players like Sachin, Ganguly, Dhoni, Sehwag, Gambhir, these will all belong to cricket team of India. Similarly, if you say river Nile or river Amazon, these are famous rivers which are not in India. So these rivers will not be part of the set of rivers of India. Similarly, there may be some students which are not students of a school, then those students will not be part of that school. Similarly, members of family, if you say neighbors, for example, you have a neighbor. So you have a neighbor X. So this guy neighbor X who is not your family will not be part of your family set. So these are some of the examples of set. To reiterate the definition, set is a well-defined collection of objects. So if you see here, Sachin, Ganguly, Dhoni, Sehwag, these are collection of objects and they are well-defined. These are all part of Indian cricket team. Similarly, Ganga, Kaveri, Yamuna, these are also a collection of objects and they are well-defined. They are all rivers of India. Similarly, dad, mom, you, your sister, your brother, uncle, auntie, these are all members of your family. I hope the definition of set is clear. Set is nothing but a well-defined collection of objects. Now let's see the implication of maths sets in mathematics world. So when I say set of all natural numbers, that is 1, 2, 3, 4, 5, 6, 7, 8, you keep on going. So this is nothing but set of all natural number. This is denoted by n, and it is this letter is widely used in mathematics. We'll see this by solving our questions. When you say n, n means it is a set of all natural numbers. Similarly, when you say integers, that is represented by z. Z is all integers. Integer can be -7, -6, -5, -4, -3, -2, -1, 0, 1, 2, 3. It goes to infinity, and here also it goes to -infinity. So this whole thing is nothing but set of all integers. We'll be using this notation z in our future examples. So please make a note of n, z. Similarly, q is set of all rational number. So rational number is anything that can be represented in p by q form, where q is not equal to 0, because once you make q is equal to 0, it will become infinite. So anything that is in this form is called. Similarly, r is a set of all real number. Anything that can be represented in number line is real number. For example, you can say 1.3, 1.7, 1.8, -1.2. Any number of this kind is called real number. So please make a note of all these letters n, z, q, r. We'll be using this in our next chapters. To clear our concept on sets, let's do some more examples. We say A is set of all even number, and now we have to find that whether 1, 7, 4, 9 belongs to this set or not. So when we say A is set of all even numbers, so let me define A. A is nothing but 2, 4, 6, 8, 10, 12, 14, 16. It keeps going. This is A. Now when we talk about 1, so we see that 1 is not there in this set. So we'll say 1 is not the member of this set. Similarly, when we say 7, we see 7 is also not member of this set. 6 is there, 8 is there, 7 is not there. So we'll say 7 is also not the member of this set. When we talk about 4, I see that 4 is part of this set. So I'll say yes, 4 is member of this set. Similarly, for 9, I see that 9 is not there. 8 is there, 10 is there, but 9 is not there. That means 9 is not member of this set. Similarly, you take any number. When you take, let's suppose 16, we'll say yeah, 16 is a part of this set. 12 is a part of this set. But numbers like 13 is not part of this set. 16 is a part of this set. It is nothing but well-defined collection. It's a collection that is well-defined. Please note, this is nothing but a collection that is well-defined. So here when we say A is a set, it is a collection of objects, and it is well-defined that all are even numbers. It's a well-defined collection of objects. After understanding sets, now let's go through some of the conventions used in sets. We'll be using these conventions to solve the questions quickly. Sets are usually denoted by capital letter. So when I say set A, which is all even number, then I'll say A is equal to 2, 4, 6, 8, ... means it continues to infinite. So if you see this, A is generally capital letter. We never say A is equal to 2, 4, 6, 8. Although we can say it won't be wrong, but this is not the convention. This is the convention. Similarly, element of the set is denoted by small letter. For example, if A is the member of A, small a is the member of capital A, then we will say that A epsilon A, that is small a epsilon A. For example, when we say A is equal to 3 or A is equal to 4, let's say A is equal to 4. Now we'll say A is the member of A because 4 belongs to this set A. So this is 4 and this is whole set 2, 4, 6, 8. So as you noticed, this member is denoted by small letter and the whole set is denoted by capital letter. Also, we have introduced a new symbol called epsilon. Please make a note of this symbol, epsilon. Epsilon means belongs to. It's a Greek symbol. So here we say A epsilon A. Similarly, let's suppose B is equal to 5. In this case, B is not the member of this set. So we'll say B epsilon not A, and A is capital. Here also you see A is equal to 2, 4, 6, 8. The whole set is A and B is nothing but 5. Since B is a member, we use small letter, and since A is a set, we use capital letter. And also please note this term that when we use term called objects, elements or members are all same. When we say A is the object of A, we can say like this also. We can say A is the object of A. We can also say A is the element of A. Also we can say A is a member of A. So we can say A is object of A, or we can say A is element of A, or we say A is member of capital A. So all these three means same. Mathematically we say A epsilon A. All these are same. Please make a note, because we will be using these terms, objects, elements and members. Please don't get confused. All are same. Thank you. Visit examfear.com to watch free educational videos, try free online test, get the best quality study material, study from the best tutor and mentors, and much more. Thanks once again.